Moving a file between two drives on one SSD, will it be copied? When moving a file within one drive, the file is not copied and deleted. The table that refers to the files is just updated. And as far as I know, that is not the case on two drives on an HDD. But SSDs are different, there is no physical space dedicated to each drive. Source. So my question is, what happens when a file is moved from one drive to another on the same SSD? Are the bytes copied and the original deleted, or is some table updated, thereby thrashing the SSD less? There's already a duplicate question here. But both answers claim each partition will have its own physical area of the drive to itself. And partitioning a hard drive actually designates physical regions for each partition. And in a comment, happy smiley, SSD is still a hard drive, it just doesn't have a disk. As far as I know, that's wrong. See here. So will someone who knows more about SSDs please tell me if they are correct in their assessment despite their mistake?
As far as I know, that's wrong. The quoted description is half correct, half wrong. But it's also half wrong for HDDs too. Partitioning a drive designates logical regions for each partition. The OS doesn't care about physical locations at all, it just asks the drive to read logical block number 314159226 and the drive itself decides where the data is located. This works the same way for magnetic and flash memory. It's actually the same as with HDDs from the last 20 to 25 years, although early operating systems used physical cylinder head sector locations, that's long gone now. You don't know precisely where on which platter LBA number 1234 is kept. HDDs even remap bad physical sectors automatically, so the same LBA can suddenly be read from a completely different physical area, just like with SSDs. So with both HDDs and SSDs, the OS just has a range of LBAs, e.g. 0 to 999,999, to read and write data from. The purpose of partitioning is to allocate subranges in it, e.g. partition A gets 10 to 499,999, partition B gets 500,000 to 999,999. Each partition has an independent file system, and file systems inside each partition cannot reference data outside it, they cannot cross the partition boundaries. For example, partition A cannot have a file whose data is kept in sector number 600000. As a result, all files moving from one to the other have to be copied in full. That said, in theory the OS may be able to ask the disk itself to duplicate data from one area to another, e.g. copy LBA number 1234 to number 567890, without having to copy it to the main memory and then back, and of course this would completely bypass partition boundaries. This could make use of the SSD's flash translation layer, for example. But in practice, as far as I know, this isn't done.
What happens when data is written to a solid-state disk is worthy of several articles. Good summary here, because it is very complicated and depends on the underlying technology. The short story is that SSDs in general cannot write 0 bits to memory. Instead, they have to zero out, erase a whole section of memory, and then they can store data after that by just writing the ones to it. Typically these days they write blocks of 512 bytes but erase a page of 8 blocks, which is 4096. This, and the fact that each write-erase cycle causes some physical wear of the memory, and the memory does eventually wear out, make SSDs very different than spinning magnetic HDDs. Setting that aside, SATA drives and a fake SARS drives do not implement a native command to copy data from one sector to another. Or at least nothing in the SATA or SARS spec requires them to, so the OS cannot count on such a command being available, so a file copy across a partition will involve reading the data from one drive sector into host memory and then writing it back out to the drive at a different sector. This is because as far as the OS is concerned, a drive is a set of numbered logical sectors, and all it can do is read from sectors and write to sectors. The OS cannot tell the drive to remap sectors. Furthermore, the file system, HFS+, NTFS, extension 3, etc., is a set of data structures that impose order on a set of logical blocks. Those data structures implement files, file names, directories, permissions, etc. So, yes, when you move a file from one directory to another, it is not copied, only the file system data indicating which directory the file is in gets updated. The concept of a partition is that it is a set of logical sectors on the drive claimed by a single file system. The corollary to that is that a file system may not access sectors outside of its partition. In large part, this is a safety feature, but it also flows from the fact that the file system's data structures are all built around accounting for every sector of the drive under the file system's ownership, and it is non-trivial to add or remove sectors to those structures. This is why you have to run special routines to adjust the size of a partition, and also why file systems insist on running on a contiguous set of sectors. So it is impractical and dangerous to implement a file copy as just transferring sectors from one file system to another. On a spinning magnetic drive, it would also be a performance nightmare, because although the drive will make exceptions for bad sectors, in general it arranges for sectors to be physically located in such a way as to optimize the read and write speed of consecutively numbered sectors. Additionally, two file systems may not store file data the same way on disk, meaning swapping sectors would not work even if it were practical. Even if they are the exact same file system types, say in TFS, one may be using encryption or compression and the other not, or both may encrypting the data, but with different keys. It is not a requirement that the data in the file is exactly what is stored on the disk. All that has to be stored is a reversible transformation of the data, so that the file system can get the data of the file by doing something with the data on disk. So unless both file systems are using exactly the same transformation, simply swapping sectors would not accomplish the goal of transferring the file data. For all these reasons, it is just too much work for too little gain for the OS writers and file system writers to implement a feature that optimizes moves across partitions for SSDs. So any cross-partition move will be a read and a write. Inside the SSD, it is a slightly different story. Although the OS did not tell the drive it is copying data from one place to another, writes to SSDs are so expensive and complicated that SSD controllers do a lot of work to minimize writes. Some SSDs go so far as to try to detect when a sector being written to storage matches a sector already stored and mark that physical piece of memory as now mapping to two different logical sectors rather than copying it, doing at the internal drive level what the OS could not. But don't count on it.
이런 게 많지만, 진짜 이런 거는